So I'm sharing just the main PowerPoint, yeah?
Yeah.
Cool. Okay. So I'm going to be presenting this paper today that is building on a collection of research by Tali Baram's lab that we have discussed previously in Methods Club. So her work kind of involves experimental manipulation of early environments and the use of animal models, to capture critical features of early life stress and then explore the relationship of early life stress with particular outcome measures. So she's explored early life adversity and this experimental manipulation of early life adversity that I'll explain in the next slide. And its link with anhedonia in adulthood, which is a blunted responsivity to previously rewarding activities. And this finding has been replicated many times. This plot on the right, which is sucrose preference, which is preference to sugar solution in adulthood. And it's been found that early life adversity reduces preference to previously rewarding stimuli, such as a sugar solution.
Okay, so can I ask you a dumb question about this?
Yeah.
When it says previously, I guess you only have one life. That, like, the way I understand this is that it's things that were previously rewarding.
Yes, so this plot looking at the preference to sucrose in adulthood, so they did find it rewarding in the first few postnatal days, and then
Oh, sorry, yeah, I get it. Thank you.
All
I
right.
thought this was
Do you know,
something.
Katie, have they shown this any other way? Because that they found it rewarding is obviously the bit that is crucial, but the bit that we can't measure. All we're measuring is do they eat more sucrose solution or not? Yeah. So have they shown the same thing in the other ways?
Maybe the facial expression.
Yeah, but I'm not sure my smile. Does anyone know if my smile?
To be fair, I'm not clued up on all other elements right now about I know they've looked at reward signaling within the dopaminergic pathway, and they've looked at opioid addiction, but I don't have a summary of those results. Okay, so how they manipulated early life adversity is using this paradigm LBN, which stands for limited nesting and bedding materials. So within any of the experiments, they split half of the dams and litters, assign them to either the LBN condition or control condition. So within between postnatal days 2 to 9, they reduce the amount of bedding within the cages and provide half of the amount of paper towels to produce nesting materials from. And then the control condition is just standard amount of bedding and enough paper towels to shred into sufficient nesting materials. Yeah, so where we've discussed this before is the links between this limited nesting and bedding materials and the impact that it has on maternal care. So it's found that limiting the materials within these first few postnatal days produces a high amount of unpredictable maternal care compared to the control condition. So these researchers explore differences in reward responsivity with this task, the probabilistic reward task. This is a schematic of what it looks like. So this has been used a lot within human participants, and then it's been reverse translated using touchscreen technology for rats, mice, and non-human primates as well. So this uses asymmetric probabilistic reinforcement contingencies. What that means is that you will receive a correct response to the one line length that you have been trained to. So you'll be presented with a line of a specific length, and then you'll have been trained to either respond to pressing on the left side or the right side for that particular length, so long or short. And you will be reinforced for your correct response 60% of the time for one of the two options, which is the rich stimulus, and then you'll only be rewarded for correct responses to the other line length 20% of the time. So that's the lean stimulus. Does that make sense? I can explain that again.
Does it make sense?
Yeah.
Okay. So yeah, the idea to take away from here is that one is reinforced at 3:1 ratio than the other. And from this task, from the results, you can calculate something called the response bias. This is based on signal detection theory, and you can calculate the bias using this equation. So it's log B. I'm not going to go into too much detail about this, but basically high bias values are produced by a higher number of correct responses for rich trials, and then incorrect responses for lean trials. So because the rich stimulus is rewarded more, you want a bias towards that to be demonstrated. And then so relating this to anhedonia in humans, so in healthy participants reliably develop a response bias towards the more richly rewarded stimulus, whereas participants with anhedonia, such as patients with major depressive disorder, exhibit a blunted response bias. So they're less likely to select the rich stimulus, even after correct identification of the rich stimulus and in the immediate trial proceeding, and then immediately preceding a trial that has been rewarded. So they're not having this long-term learning of reward value.
Katie?
Yep.
Why do they make it like probabilistic rather than the rich always gives you what you want and the other one doesn't? Is that just because like everyone would then choose the rich? Does it have to
Yeah.
be okay.
Yeah. So there's like some degree of uncertainty, and it's like I was looking at slight differences in reward learning. So yeah, it's not just learning that one side would give you the reward. Is that what you mean?
Yeah, I was just thinking like if you had anhedonia, if it was just that it was all the rich stimulus always gave you something good and the other one didn't. Like why not just have it like that? But maybe even if you had anhedonia, you would still in that case choose the rich one.
Yes. Yeah. And I'll speak about it more within the results. Like even within the early life adversity group, there is still a clear like response bias to the rich stimulus, but then it's like looking at the differences between how they also engage with the lean stimulus as well. So there's still like a slight preference to a slight response bias being learnt to the rich stimulus.
And sorry, Katie, I didn't quite follow the paradigm because my brain's not working very well because I've just come out of a lot of meetings. But just explain to me, how can we be sure that it's a difference in how rewarding they find the reward as opposed to how quickly they learn the difference between what a reward is and what gets a reward and what doesn't get a reward, because they strike me as very different things. How quickly I learn the difference between what gets me the reward and what doesn't get me the reward isn't anything to do with anhedonia. That's to do with statistical learning.
Basically this study is building on previous work that has found this blunted response bias, and then that's why this current study is using the computational modeling to kind of parse the results into looking at learning rate and then reward sensitivity. So hopefully that will be explained in these results.
Fine.
Yes, so yeah, as I just said, this building on previous work from the same researcher that has replicated this blunted response bias in the task during adulthood in 2 separate cohorts for the early life adversity group compared to the control rats. So then the researchers wanted to look at what exactly is driving this blunted reward responsivity. So current study is looking at the effect that early life adversity has on task performance beyond this response bias metric. So it uses trial by trial reinforcement learning examined using the Bayesian computational modeling and then probability analysis as well. So it's looking at what is driving these differences in reward responsivity. Is it driven by learning rate or reward sensitivity, which is 2 parameters of reward learning, which I will explain in more detail. So reward sensitivity is the pleasurable impact of rewards, so how sensitive we are to the pleasurable feedback of reward, and then learning rate is the subject's ability to learn. So how quickly, as you said, Sam, how quickly they're learning from reinforcing consequences.
Katie, sorry, can you
Yes.
just explain, because we're not directly measuring the pleasurable impact of a reward. So can you express that in terms of what they are actually measuring? So the difference in how much they look to a rich reward versus a lean reward.
Yes. Should I keep going or do you want me to? I feel like if
No,
I
but
don't.
that was that right, what I just said?
Wait, say that again, sorry.
Go back a slide. So reward sensitivity, is it the difference in how much they look to a rich reward versus a lean reward?
It's how sensitive they are to the preceding reward. It doesn't necessarily matter what type. They do go into that in.
How sensitive they are. Okay, fine. That's good.
Yeah.
Sorry, I'm way behind everyone. I thought my brain's not working very well.
No, it's okay. Yeah, okay. Any other questions? Okay, so just to go over the methods quickly. So there's N of 32. As I've mentioned, there's the limited bedding and nesting protocol. So halves fit into LBN or control. And then around postnatal day 100, they're transferred to a different hospital and then they began training for this task. So then they were trained to respond to either the left or right response box, depending on the length of the line. And this was counterbalanced. So for some, long line was respond to left, and then for some, short line was respond to the right. And then when the rats were around 80% accurate for 2 consecutive sessions, then that's when they began testing on the probabilistic task. Yeah, this is just going over it again, but if everyone is clear on the setup of the paradigm. Just to highlight that the lengths of the lines could be different, would be different for different rats. This was dependent on what they determined. What was I saying there? Yeah, so they just kind of based the length of the lines on the rat's accuracy during the final 2 line length discrimination training sessions. This was so that the current study wasn't exploring kind of the rat's accuracy in differentiating 2 different line lengths. It was to look at the role of reward learning. So just to go into a bit more detail about reward sensitivity and learning rate, these are based on temporal difference learning, which is a mathematical formulation of reward learning. So if you have a game where rewards are administered randomly on a select number of trials, so in the case of the current task, that would be 30 rich rewards and 10 lean rewards within a block of 100 trials. So we think of reward received in trial T as RT equals 1, and then no reward received in trial T as RT equals 0. And then we have QT, which is the agent's expectation of the average reward that might be gained on a given trial. If you look at the first formula here, derives prediction error, which is the delta symbol at the end. Prediction error is utilized to adjust future expectations. So Q at T plus 1 would be Q at T plus this prediction error at time T multiplied by the learning rates. And then we have the second formula here at the bottom, which kind of expands on how you calculate prediction error, which basically represents the discrepancy between the obtained, so either RT equals 1 for a reward or RT equals 0, this bit here, times the reward sensitivity minus the expected reward. So that's the Q at time T. So this is just kind of demonstrating how this framework of temporal difference learning, which describes reward learning, from these equations you're able to derive two parameters, which are the two parameters of interest within the current study. So the top one, that symbol is for reward sensitivity. So the larger the reward sensitivity, the more sensitive a subject is to the reward. And then the bottom one is learning rate. So that captures the extent to which reward prediction error modulates learning. Because as you can see here, sorry, this one, the learning rate is times by the prediction error. So a higher learning rate means a large impact of reward feedback of the prior reward on the current decision. So
Katie,
yeah,
like why is there so much focus on the prior one? Like, because you could be doing, like, say, I don't know how many trials they do, but 30 trials of and they might have learned a preference for one over another. Is the one that they've just done expected to have an outsized impact? Or like, why is it only T plus 1?
yeah, yeah, that's a great question. I guess they are just looking at the preceding trial when they've separated it into different preceding trial types. They've only accounted for the trial preceding the current one, so
Okay.
I don't actually know why. Okay, so, oh, sorry, was there another question? No? Okay. So the Bayesian model that the experimenters use fitted 4 different types of reinforcement learning models to the group level data. So just to quickly go over each of the 4 models. So the first one, the first 2 are just stimulus action models. The differentiation between the 2 is that the first treats not getting a reward or missing a reward as a punishment, so that weakens the association, weakens the learning, whereas the second one, missing a reward, means no learning happens. rather than it being active punishment. And then the third model, the belief model, is similar to the first two, stimulus action learning, but it accounts for a degree of uncertainty. So it believes that the agent assigns reward to both stimuli options with only a certain preference for the actually presented stimulus. So accounting for an element of uncertainty within what they're being presented with. And then the fourth one is the most simple model. It just learns differences based on action, so preference for pressing left or right. So they had these 4 different models to choose from. So they needed to select the most suitable model. So they did this through integrated group level Bayesian information criterion. So they were just comparing how well different models explain the entire sample. So that's why they're doing it on a group level. And they were looking for the model with the lowest IBIC value was considered to be the winning model. So this is just how they selected the best fitting model. Simpler models that fit well are preferred over complex models that fit slightly better, and they ran this test 3 times for robustness. And every time, in all 3 repeated runs, the belief model had the lowest IBIC value. And then for additional verification, they compared it to surrogate data. So they simulated 500 times for each subject their response bias within the task. And then this closely fitted to the response biases predicted by the belief model. So that's why they decided to proceed with model 3 for the paper. So
Sorry, Katie, when
Yeah.
you say the x-axis on that plot, can you just talk us about why we'd expect, given Gio's point, that behavior is changing over sessions?
wait, sorry, what do you mean, Sam?
Given Gio's point that it's basically just a one back modeling throughout, why would the surrogate data analysis predict that the response bias would change between sessions 1 and 2 and 3, but not between sessions 3 to 5?
I suppose because, yeah. No, I'm actually confused about whether it is just one back, because, yeah, you're right, this is showing evidence of learning over the course of the sessions. Yeah, I'm not sure. Maybe we can come back to that at the end.
But maybe they have something in common, no? Like the sessions. Sorry, I forgot what were the sessions, but presumably the tasks are quite similar. Exactly. So to press something, no?
Yeah,
So they
Yeah, it
learn
is the
that they
same.
need to press.
yeah, you're exactly right. So it's the same task 5 times, and they've been trained with the same response. So choose left for the long stimulus or right for the short one. But then Sam's question is just about the computational model, so whether more than the time, the trial before is involved in the...
Marta, how would that explain the surrogate data? Yeah.
No, the surrogate, I don't know, but the real data, maybe they get. I don't know. Sorry.
Yeah, you'd expect the real data, because the one back modeling that they've got isn't quite accurate, but yeah, it's just striking that you get that in the surrogate data too. I don't really understand how these equations work well enough, because Like just go back to the equations, Katie, because the QT would slowly vary over time, right? Yeah, I don't really understand these iterative equations well enough.
Yeah. So these equations are just to demonstrate what the model's basing the two parameters on, but I guess maybe these aren't the exact equations that we use for the computational model used in this paper, but now I'm not sure. So they selected run 1 of model 3 as that was the best fit of the data, exploring the difference between the two groups for reward sensitivity and learning rate, and they found that there was a significant difference for the reward sensitivity between the two groups, but not a significant difference between the learning rate. So differences in response bias are influenced by these differences in reward sensitivity and not the speed at which the rats are learning at.
So can I ask something?
Yes.
They're both learning, but the sensitivity is different.
Yeah, so we look at these plots, this demonstrates how both groups have learnt some response bias to the rich response. So learning that overall they should select the rich response more times than the lean response. But there's just slight differences between the groups. So the control group compared to the early life adversity group, when there is when the prior response awarded is a rich response, the early life adversity group were more likely than the control group to still select the lean response. And this effect occurred no matter what the preceding trial was. So we just go to this one. So this is demonstrating the same thing. For the prior lean response rewarded, can show, this graph shows that when comparing the groups, that the early life adversity group chose the lean response more often than the rich response as well.
I just don't get the difference between these two concepts, sensitivity versus learning, because like in some papers, learning is also inferred as a form of sensitivity because you learn it. That means you choose the right, the rewarded choice. So that means you have learned it, but how is it different? How is sensitivity different from having learned something and approach something that is more rewarding? I just don't understand the concept.
Yeah, so I guess that's what this the paper is based on, this theory of reinforcement learning and this idea of temporal difference learning. So that's the idea that reward sensitivity and learning rate are both involved within reinforcement learning. So they're both like contribute to how an agent learns from reinforcing consequences. Does that make sense?
It's about it. Sorry.
Okay.
This is Maria, you on at home?
She's here.
She's in the room. I think.
Oh, you're there. This is making me think. I wonder whether another possible driver of this might be your paper on the two words we can never remember what they mean. Stochasticity versus no what? Oh, phasic and tonic. Now we're calling it that. But I wonder. Just go back to the equation. Sorry, Katie.
Yeah.
I wonder whether another thing. I don't really understand how this type of modeling works, but maybe it's possible that. So Maria presented a paper on this idea of how the difference between trial by trial reliability, yeah, versus how quickly your responses gradually evolve over time, yeah. And I'm just wondering if some of the difference that they're coming up with, this difference between reward sensitivity and learning rate, might be to do with the fact that that same difference between how consistently they do some things from one trial to another, as opposed to how gradually they can change over time. Yeah, that same distinction. Yeah.
And
see
how are
what-
you measuring that?
Well, we are gonna do it with heart rate. It's our.
Yeah, but how do they do it in the paper that you were presenting?
Katie presented that paper. Remember?
Oh, sorry, Katie, you presented that paper. Sorry,
Oh,
it's part
oh,
of
the
Maria's
stochastic
PhD.
and volatile noise.
Yeah. Yeah. Do we? Could that same difference be explaining this difference between reward sensitivity and learning rate that they're talking about as a thing? Could they be talking about the same thing?
Yeah, no, I think they're talking about quite similar things. Yeah, because they had the learning rate, and that's what they were measuring within that model. They were varying the amount of different types of noise, and then looking at the learning rate.
But the explanation for what they were looking at is very different, though, right? Nothing to do with the Hedonia or reward sensitivity.
No, but this is obviously like relating it to the environmental manipulation as well.
Yeah, but if the very, very coarsely unscientifically put, if the low reward sensitivity were just more erratic, yeah, more inconsistent in their responses from trial to trial, that's what I'm trying to get at. I mean, that's very coarsely expressed.
Yeah. I'm not sure about that. Okay. That's the end, actually. Quite quick. So just to summarize, so the current study found that reward sensitivity was significantly impairing early life adversity group compared to the control group, but a learning rate did not differ significantly between the two groups. And then when they looked at the response bias within the early life adversity group, looked at their responses in relation to the preceding trial, they found that they, regardless of the preceding trial, were less likely to select the rich associated response compared to the control group. So they're showing a reduced sensitivity to reward over the control group. So this is adding to the findings of the previous paper about this blunted adaptive response bias in early life adversity subjects. So to conclude, this is exploring subtle differences in reward sensitivity and kind of highlighting that potentially what is affecting subjects who've experienced early life adversity is not the speed at which they're learning, but how rewards are interpreted that might influence performance on a task. So think of all the literature kind of linking differences in cognitive performance and unpredictable environments. Early life stress might not be differences in learning mechanisms, but just how they're motivated by rewards. And potentially this is an adaptation to harsh environments. So when resources are more unpredictable, you may become less sensitive to rewards. as that's less beneficial than reward seeking. And then kind of thinking about potential applications to social policy, maybe and interventions, equalizing opportunities, think about targeting motivation and kind of resensitizing reward systems to equalize opportunities for children who have experienced early life stress and adversity.
Do you
And
know like how do you resensitize reward systems?
Yeah, very vague. I just put that in. No, I don't.
No, it sounds really interesting, like, but I don't know how you do it.
Yeah, I guess if these results are showing that there's just like a reduced sensitivity, so just kind of I don't know, maybe like the need for like more persistent rewarding
Yeah.
potentially work.
You know, like you mentioned opioid addiction, and I can't remember what the context was, but is the idea that like if you're less sensitive to subtle like things that are subtly rewarding as opposed to something else, you might seek out things like you might be only sensitive to something that is extremely rewarding.
Yeah, definitely. Yeah, I was thinking of like the theoretical biological explanations of like adaptation to unpredictable environments and kind of like the difference between delayed gratification and instant gratification. I think, yeah, that definitely ties into that. Thank you.
Any more questions? Good, thanks, Katie. That is a tricky one. I'm not sure. I don't know if I buy it. Well,
Yeah, fair.
yeah, there's just what other things could have explained that other than what they were saying. Yeah. But yeah, really nice, really very nice to present to. So well done.
Thanks.
Right, bye everyone. Thank you.